Hi everyone, we are starting uh, trigonometric identities in this class. Very important, and even we solve some of the example problems before exercise 11.4. So first we'll see about trigonometric identities. Trigonometric identities. Using this, we are going to solve the problems. So trigonometric identities, first very important identity we have, that is sine square theta plus cos square theta is equal to 1. So in place of theta it can be angle A. Theta is an angle here. So cos sine square A plus cos square A is also 1. Sine square B plus cos square B is also 1. Any angle in place of theta it is going to be equal to 1 only. That you have to remember. This is identity number 1. Another identity we have is 1 plus tan square theta is equal to secant square theta. So in place of theta, same as identity 1, here you can have 1 plus tan square A is equal to secant square A. Both are same. Only in place of theta, we are writing it as A or B or C. Any angle you can write. Another identity we have is 1 plus cot square A is equal to cosecant square A. Cosecant square A. Okay. This is valid for all the angles except A should not be 0. For that it is not. And similarly, when we come to the 1 plus tan square A equal to secant square A, here A should not be equal to 90 degrees. Okay. Why it should not be equal to 90 degrees? Because secant A here, I'll explain that. Secant A is nothing but 1 by cos A, 1 by cos A, and A, suppose if you take 90 degrees, 1 by cos 90 degrees, it is 1 by cos 90 is nothing but 0. 1 by 0 it is going to be infinity undefined. So A should not be equal to 90 degrees. Other than other angles like 45, 30, you can have 30 degrees, 60 degrees. For those values it is valid. Okay. So we'll see now how to use these identities in solving the problems. Okay. So they have problem number 1 we are going to solve. Suppose they give the question as evaluate. Okay. Evaluate. Some of the problems they are going to give evaluate, some they are going to give prove that, some going to give it as show that. These are the different types you are going to have. So if they ask evaluate and they give the problem like sine square 15 degrees plus sine square 75 degrees divided by cos square 36 degrees cos square 54 degrees. Okay. So here what is sine square 15 we can write, and what is sine square 75 we can write. That you have to identify. So sine square 15. So we can write it as sine square 15 as sine square 90 minus how much? 75. Okay. Sine square 90 minus 75. This can be written as sine 90 minus theta. It can be written as cos theta. Here we can write it as cos square 75. Cos square 75. Okay. Similarly, this is cos square 36. Another value here we have cos square 36 degrees. We can write it as cos square 90 minus 54. Okay, why only 54? 90 minus 54, it is 36, because here already they have given cos 54. Sum of 36 plus 54, 90. So from that we can write cos square 90 minus 54. So cos 90 minus theta is nothing but sin theta. Here we have sin square theta, sin square 54 degrees. Okay. So now we can replace these two. Sin square 15 can be replaced with cos square 75, and cos square 36 can be replaced with sin square 54. Okay, so now in place of sin square 15, what they have given in the numerator, we are going to write it as cos square 75 degrees. Already sin square it is there 75 degrees, and divided by cos square 36 can be replaced with sin square 54 degrees plus cos square 54, already it is there. So as we have seen earlier, identities, cos square theta plus sin square theta is 1. So in place of theta it can be a, b, c or 75 or 30, anything it is. Cos square 75 plus sin square 75, it is going to be 1. All divided by sin square 54 plus cos square 54, same as cos square theta plus sin square theta, it is 1. So 1 by 1 we get it as 1. Okay. Now another problem, here we have sine 5 degrees, okay, cos 85 degrees plus cos 5 degrees into sine 85 degrees. Sine 85. This they are asking to evaluate. So whenever they ask to evaluate, you have to find what is equal to this value. Okay, we'll write like sine 5. Here if you observe sine 5 and cos 85, 5 plus 85, it is going to be 90 degrees. That's how they give. Here we have cos 5 into sine 85. 5 plus 85, in this case also it is 90 degrees. So carefully you have to change sine 5. We can write it as sine 90 minus 85. Sine 90 minus 85, because here 85 it is given. So sine 5, this sine 5 is replaced with sine 90 minus 85 into cos 85, it is there, that we have just copied here, plus cos 5 can be written as cos 90 minus 85. Cos 90 minus 85 it is, into we have sine 85 degrees. Sine 85 degrees. So we know that from the earlier, for sine 90 minus theta, it is nothing but cos theta. We have other videos where I have explained sine 90 minus theta. This 90 minus theta, in place of theta here we have 85, it is cos theta. In place of theta we are going to write it as cos 85, and cos 85 already there. Now similarly cos 90 minus 85, it is nothing but sin 85. Cos 90 minus theta is sin theta. Okay, this is not division, I have underlined it is. So here sin 85 into sin 85. Okay, so cos 85 into cos 85, we can write it as cos square 85 degrees. Sin 85 into sin 85, we can write it as sin square 85. Now can anybody tell what is equal to? Yes, just pause the video and think and write the answer. cos square theta plus sin square theta. In place of theta here we have 85. Okay, it gives it as 1. Okay, right. If you are able to do that is very good. Next problem number 3, here we have secant, they have given secant 16 degrees, cosecant 74 degrees minus cot 74 degrees tan 16 degrees. Okay, so this also we know that here what we know that WKT you can write secant 90 minus theta, it is nothing but cosecant theta. Okay, similarly you can write cosecant theta, any one of them we are going to change, secant to cosecant we are going to change. Okay, so here secant 90 minus 74, 90 minus 74 how much, 16. So that in place of secant 16 we are writing it as secant 90 minus 74. 90 minus 74 is 16. Okay, secant 16 we get secant 90 minus 74, we can write it as cosecant 74 degrees. Okay, so we have cosecant 74 into cosecant 74. Now similarly we are going to replace here this tan, we can replace. Why only tan we are going to replace, not cot? Because we have the relation between secant and cosecant, that is identity we have 1 plus cot square a or cot square a plus 1, it is nothing but cosecant square a. This identity we have, so we are going to change this secant to cosecant, so we get cosecant square here, and this tan to cot, so we get cot square. Okay, so you have to be carefully when you change. Why we are changing? So that we are going to go to reach to this identity where 1 is equal to, if you take this cot square a on the right hand side, we get it as cosecant square a minus cot square a. So this we have this form, if you are able to bring the given uh, equation or given value, this one secant 16 cosecant 74, we bring it in cosecant square form, cot 74 tan 16 we bring in cot square, right? So this secant 16 is replaced with cosecant 74. Similarly tan 16 can be replaced with tan 16 degrees is equal to tan 90 degrees minus 74. So tan 90 minus theta is nothing but cot theta, cot 74. So tan 16 is replaced with cot 74 and our secant 16 is replaced with cosecant 74. So what we can write here, cosecant, okay, secant 16 is replaced with cosecant 74 into already cosecant 74 is there minus cot 74 and tan 16 is replaced with cot 74. Here tan 16 v is equal to cot 74 we got. So cosecant square 74 we get cosecant 74 into cosecant 74 we get cosecant square 74 minus cot 74 into cot 74 we get cot square 74 degrees. Just now we have seen the identity that cosecant square a minus cot square a is equal to 1. Whatever the angle here a, it should not be equal to 0, other than a equal to 0. This cosecant square 74 minus cot square 74 is equal to 1. That is from the identity. Okay. So this we have done. Next, this given example 11 before 11.4 exercise we have. I am writing the example 13 and the page number 294 in the mathematics textbook in trigonometry chapter that we are solving. So what they have asked, show that cot theta plus tan theta is equal to secant theta into cosecant theta, and they have mentioned that theta is greater than 0 and less than 90 degrees. For this range of theta values only this relation is valid. Okay, so here we have LHS and RHS. As I said earlier, you're going to have evaluate, show that, evaluate one type of problem, show that another type of problem, prove that, show that are almost same. So you can start from LHS, some cases RHS also you can start. Here you can start with LHS cot theta plus tan theta. And I think if you remember, as we have seen in earlier videos, cot theta is nothing but cos theta divided by sin theta. Cos theta plus cos theta divided by sin theta is nothing but cot. Similarly, tan theta is nothing but sin theta by cos theta. Okay, so if you take the LCM here, we get sin theta into cos theta. Sin theta into cos theta is LCM. So sin, when we take the LCM, sin theta cancels. We have cos theta into cos theta, we get it as cos square theta. Similarly, this cos theta and this cos theta get cancelled. We have sin into sin, we get it as a simple LCM, it is sin square theta. So what is cos square theta plus sin square theta? How many of you able to tell it is equal to 1? Okay, and in the denominator we have sin theta into cos theta. So 1 by sin theta, okay, into 1 by cos theta we get. 1 by sin theta into 1 by cos theta. 1 by sin theta we have it as cosecant theta. 1 by cos theta we can write it as secant theta. This is what they have asked, right? This is our RHS. Hence, it is proved, you can write R, it is equal to RHS. Okay. Next we have example number 14. Example number 14. What they have asked is show that, okay, this type of problems they have asked, show that tan square theta plus tan to the power of 4 theta is equal to secant to the power of 4 theta minus secant square theta. Okay, so this is what they are asking to show that. So you can start here from the LHS again. Okay, LHS, what we have LHS, tan square theta plus tan to the power of 4 theta. So you can take out tan square theta common from both, tan square tan to the power of 4 theta, tan square theta if you take out common, from we get 1 plus tan to the power of from 4, if you take out 2, okay, we left with tan square theta. Okay, it's simple here. What you have to do is whenever we are taking tan square theta common outside, here we have 4. 4 minus 2, it's going to be 2 left here. Okay, that's how you're going to write it as tan square theta. Okay, right. So now we know that 1 plus tan square theta, just in the beginning of the video we have seen 1 plus tan square theta is how much? Secant square theta, right? So we have tan square theta into secant square theta. Now this we have the same, from the same identity, 1 plus tan square theta is secant square theta. So this tan square theta we have to replace with secant, because in the RHS what they have asked, both the terms are in secant, both the terms are secant. So we can't stop here by replacing 1 plus tan square is secant square theta, because they asked both the terms are secant. So this tan square theta also we are going to replace in terms of secant, then both the terms of RHS we get. Okay. So here tan square theta is equal to, we can bring this 1 on the right hand side. So tan square theta is equal to secant square theta minus 1. So the tan square theta here, it is tan square theta is replaced with secant square theta minus 1. Secant square theta minus 1 into what here we have, secant square theta. Okay. So secant square into secant square, what happens, bases are same, powers we are going to add, 2 plus 2 it is going to be 4. So we get secant to the power of 4 theta, okay, minus this 1 into secant square theta, it is going to be secant square theta. This is our RHS. Okay, right, it is proved. Next we have another example problem and we'll stop for today's class. Next class we'll start the exercise 11.4. So here you can see that prove that they have asked square root of 1 plus cos theta divided by 1 minus cos theta is equal to cosecant theta plus cot theta. That is what they are asking to prove. That the condition here what they have given, the angle theta should be greater than 0, less than 90 degrees, greater than 0 and less than 90 degrees. Okay, so we start the solution for this. Here we are going to start from LHS. LHS what they have given, 1 plus cos theta divided by 1 minus cos theta. This is a very important question. So here how you are going to solve is, you are going to do the rationalizing, like 1 minus cos theta in the denominator we have. So we are going to multiply and divide with 1 plus cos theta. Multiply and divide with 1 plus cos theta. Why we do this? If you cancel 1 plus cos theta, 1 plus cos theta, we get it as 1 only. Like here if it is 1, 1 plus cos theta by 1 minus cos theta into 1 is, it is same, there is no change. We get 1 plus cos theta by 1 minus cos theta only. Now in place of 1, we are writing 1 plus cos theta by 1 plus cos theta, it is equal to 1. So why only 1 plus cos theta you have to choose? Here we have 1 minus cos theta. So when we are multiply, you have to multiply with 1 plus opposite sign. So in the numerator we get 1 plus cos theta into 1 plus cos theta, we get it as 1 plus cos theta square divided by, here 1 minus cos theta into 1 plus cos theta, it is a minus b into a plus b, we have a minus b and a minus b into a plus b, or a plus b into a minus b, we have a square minus b square. A is here 1, so 1 square, b is cos theta, so cos square theta, 1 square is 1 only, 1 minus cos square theta we get in the denominator, 1 minus cos square theta. Can anybody tell what is 1 minus cos square theta? Okay, just pause the video, think for half minute. We have the identity that sin square theta plus cos square theta is how much? 1. Okay, so if we bring this cos square theta on the right hand side, we get sin square theta is equal to 1 minus cos square theta, 1 minus cos square theta. Okay, so this 1 minus cos square theta of the denominator is going to be replaced with sin square theta here. And in the given problem, in the numerator we got 1 plus cos theta square. Okay, 1 plus cos theta square is there, divided by, in place of 1 minus cos square theta we have sin square theta. So here powers are same, so we can make it as 1 plus cos theta divided by sin theta as a group, and we can write it as whole square, because powers 2 for numerator 1 plus cos theta and denominator sin theta, power is 2 only. So we can combine and we can write it as 1 plus cos theta divided by sin theta whole square. Now this square and square root will get cancelled. We get it as 1 plus cos theta divided by sin theta. So now we can write this denominator sin theta individually for 1 in the numerator as 1 by sin theta plus cos theta divided by sin theta. And what is 1 by sin theta? How many of you remember? 1 by sin theta, how much? It is cosecant theta, okay? And cos theta by sin theta, how much it is? Cot theta, okay? So that is what they asked to prove. This is our RHS, okay? That is, we ended with the example problems, and they have given try these problems as page number 294. That also we have done. In the next class we will solve exercise 11.4, which is the last exercise of trigonometry. Thank you very much for watching. Please share and subscribe.